This is a review on solving systems of equations. The first method that we learned for solving systems of equations is graphing. If you wanted to solve this system of equations using graphing, you need both equations in slope-intercept form. The first equation, y equals 2x plus 8, already has our slope and y-intercept. The second equation we can put into or manipulate into slope-intercept form. There's a number of ways to do so. The fastest way is to divide both sides by 3, canceling out the 3 outside the parentheses, leaving negative 2x plus y equals 4, and then adding 2x on both sides. Once you do this, you'll see the second equation has a slope of 2 and a y-intercept of 4. If we were to just even sketch a graph of this situation, y equals 2x plus 8 and y equals 2x plus 4, we'll notice the lines are parallel. That means there's no solution. So one way to get the answer is by graphing. You might have noticed a faster way, however, is to use substitution. One reason we know it's good for substitution is there's a variable all by itself. So we know that y is the same thing as 2x plus 8. So in our second equation, instead of y, well, we can replace that with 2x plus 8. So when we rewrite that, it would become 3 times negative 2x plus, and then again, instead of y, we would write in 2x plus 8. All equals to 12. If we combine these like terms, 2x and 2x, we'll see they cancel out, leaving us with just 3 times 8 equals 12. Well, 3 times 8 is 24, and 24 does not equal 12. So here the variable canceled out, and it's not true. When this happens, we know there's no solution. So that's another way we can determine or verify the solution to the system of equations is no solution. There isn't. For question number 2, it's asking you to investigate and think about the third method that we learned called elimination. This system right here is great for elimination because we can see the x variables are lined up, the y variables, the equal signs, and the constant terms. Everything's all lined up. In order to use elimination, you might notice that we need to have opposite and equal coefficients. So right here, for example, 2 and 3, those wouldn't cancel out. 2y and minus y, those wouldn't cancel out. So one thing we can do in systems of equations is we can multiply entire equations by a number. So for example, if we manipulate this and multiplied it by 2, well then I know this is going to become negative 2y, and that will cancel out with positive 2y. So for example here, if we did this, this would become 6x minus 2y equals 8. Up on the top, 2x plus 2y equals 16. Question number 2 isn't actually asking us to solve, though. It's asking which of these 4 options is exactly the same as what we started with. Well, you notice answer choice 2 is what we just kind of constructed right there. If you multiply the bottom equation by 2, it ends up being the same thing. Answer choice 1, you'll notice, had a fake out. They forgot to multiply the last constant term by 2, and they had 4 in here. Answer choice 3, you'll see, has a couple mistakes in their work. They tried to manipulate by making it smaller. But when they divided everything by 2, they forgot to divide the 16 by 2. And finally, number 4 there, you'll notice they multiplied everything on the top by 3. That was successful. However, on the bottom, there's a minus sign. So this wouldn't have been 6x plus 2y. If we multiplied everything by 2, it'd be 6x minus 2y equals 8. Finally, for question number 3, we have Jack, who's buying these 3 slices of cheese and 4 slices of mushroom. I'll use cheese to represent, C to represent cheese, and M to represent mushroom. We know how many slices, so the question that we're trying to find is how much does cheese cost and how much does mushroom cost? We know Jack bought three slices of cheese and 4 slices of mushroom. His total cost was $12.50. Grace bought 3 slices of cheese and 2 slices of mushroom, and her total was $8.50. So we can represent the system of equations like this and then solve. You'll notice that we already have 3c and 3c, so we just need to subtract these two equations. So 3c minus 3c will cancel out. 4m minus 2m will be 2m, and 1250 minus 450 will be 4. Divide both sides by 2, and we'll get our answer for mushroom. Mushrooms are $2 each. The correct answer was answer choice number 2. Flipping over to the back side, question number 4 was a part 2. Actually, excuse me, I believe this one was a part 3, because there's a couple different things going on. So part A asks us to write one equation representing the cost of rental M months at Ron's rental, and one equation representing the cost of rental for M months at Jose's rental. So that's part A. Let's do that first. So Ron's rental has a cost, C, so it says if C equals the cost, of $100 plus $10 per month. And again, we need to use M for months. You also could have written C equals 10M plus 100. For Josie's rental, again, we'll need to write an equation with cost, C equals. Josie's rental is $20 wear and tear, and $20 a month. You could also write that as 20M plus 20. After that, on the accompanying grid, it asks you to graph and label each equation. So we'll start by graphing Ron's rental. Ron's rental starts at a y-intercept of 100. The number by itself in slope-intercept form is the y-intercept, and it goes up with a slope of 10 over 1. On this graph, each line represents 10, so as the function increases, it will move at a constant rate, going up $10 for every month. Josie's rental starts at a y-intercept of 20. However, Josie's rental goes at a slope of 20 over 1, so it goes up 2 boxes every month. Eventually, we'll notice that common point that's shared by both of the lines is at eight months. All right, so before we move to part C, let's make sure we got all the points in part B. It says to graph and label each equation. So we can say that Ron's equation would be this one right here. And the equation for Ron's was C equals 10M plus 100. Josie's rental had an equation of C equals 20M plus 20. So now we've labeled both. Finally, from your graph, determine in which month Josie's cost will equal Ron's cost. Well, they'll be the same. So for part C, costs are the same. At 8 months. All right, last but not least, we're asked to find the difference between two numbers being 28. The larger number is 8 less than twice the smaller number. Find both numbers. All right, so when all else fails, I use x to represent one variable and y to represent the other. We'll have to choose one to be bigger and one to be smaller. So I'm going to say let's let x equal the larger number. Let's let y equal the smaller number. Step 1 in any system of equations, or really any word problem, is to define your variables. So we've now done that. We defined our variables. From there, to produce an algebraic solution, we're going to have to write two equations. The first equation is that the difference between two numbers is 28. So if I have the larger number and I take away the smaller number, it will be equal to 28. The second equation says the larger number is 8 less than twice the smaller number. So the larger number is x. The larger number would be x equals 8 less than twice the smaller number. So twice the smaller number would be 2y. 8 less than that would be 2y minus 8. So these were our two equations, equation 1 and equation 2. From there, there's a number of ways to solve. I think the best way to solve this would be using substitution. We see the x is by itself here. So we can take all of 2y minus 8 and replace it for x up here. So we'll have 2y minus 8 minus y equals 28. Solving that further, combining like terms, we'll have y minus 8 equals 28. So y equals 36. From there, we can plug back into any equation. So for example, we have x equals 2y minus 8. So we know x is going to be 2 times 36 minus 8. And 72 minus 8 gives us our answer of 64. So the two numbers are 36 and 64.